student, welcome to my channel Mathematics Corner. I am Mukul, Sarma, subject teacher. Today I shall also discuss solution of some problem in miscellaneous exercise chapter number 5 and one more problem which is not in the textbook but it is also important for a examination point of view. This is my last class for complex number. So first problem is find the non-zero solution of 1 minus I modulus power x is equal to 2 to the power x. We have to find the value of x which must be non-zero and integer. Solution. This is solution. Here given 1 minus I whole to the power x, 1 minus I modulus power x equal to 2 to the power x. This is a plus ib form, therefore modulus, therefore it is a real part is 1, it is 1 square, and imaginary part is here minus 1, therefore minus 1 square, it is x. A minus b, aib from this I, there is 1 is there, therefore 1 square plus real part is 1, imaginary part is minus 1, therefore 1 square plus minus 1 square, a square plus b square root over, this is the modulus, power is x, therefore x there. This can be written as 1 plus 1 root over power x, that is root over 2 to the power x, 2 to the power x. Root 2 is equal to 2 to the power half. We know it, this is root over 2 is 2 to the power half, therefore 2 to the power half x power 2 to the power x. Therefore 2 to the power 1 by 2 into x, 1 by 2 into x. This is the properties of this is power, this is power, this is 1 by 2 into x. This is 2 to the power x by 2, 2 to the power x. 2 to the power x by 2 divided by 2 to the power x, 2 to the power x, dividing both sides by 2 to the power x. Here this is the properties of, and this is 2 to the power x by 2, 2 to the power x, therefore this is x by 2 minus x, and this is cancelled, and that is 1. 2 to the power x by 2 minus x. If we take LCM, that is 2x minus 2x. We can write it to the power 0, because something to the power 0 is equal to 1. Therefore 2 to the power x minus 2x, this is minus x by 2 is equal to 2 to the power 0. This can be written as, there is 2 to the power minus x by 2, 2 to the power 0, therefore minus x by 2 is equal to 0. Minus x by 2 is equal to 0. This implies minus x is equal to 0. This implies x is equal to 0. We have got that the value of x and this equation is 0. That's why, but it is 0 But we have to find a non-zero solution, so there is no non-zero solution. So there is no non-zero solution. That is the problem. Next problem, this is also most important. This is next is this is find theta such that 3 plus 2i sin theta divided by 1 minus 2 sin theta is purely real. This is purely solution. That is 3 plus 2 sin theta 1 minus 12. This is I, 2i sin theta. Here is a minus, we have to remove I from denominator, therefore 1 minus 2i sin theta. Its conjugate is 1 plus 2i sin theta. To give 1 minus 2i sin theta, we have to put 1 plus 2i sin theta. Or this will be multiplied in numerator also, 1 plus 2i sin theta. Here 3 plus 2i sin theta. Now multiply, this is 3, 1, that is 3, 3, 2, this is 6i sin theta. 2i sin theta into 1, that is 2i sin theta, plus 2i sin theta, 4i square sin square theta. And it is 1 minus 2i sin theta 1 square, a square minus b square, a minus b, a plus b, a minus b, a plus b, a square minus b square. Here b is this. Therefore 3 plus 8i sin theta, and this I square is there, therefore minus 4, I square is minus 1, this is minus 4 sin square theta. And this is 1 plus, this is 4, this is 1 minus 4, I square, this is 2i whole square, 4i square sin square theta. This is here real part is 3 minus 4i sin square, 4 sin square theta. This is real and this is imaginary, I 8 sin theta. Here 1, there I square is minus 1, therefore minus 1, this is plus 4 sin square theta. Now we can write this as 4 sin square theta, 3 minus 4 sin square theta, 1 plus 4 sin square plus I 8 sin theta, 1 plus 4 sin square theta. Here, since this is purely real, therefore imaginary part is, since 3 plus 2i sin theta 1 minus 2i sin theta is purely real, Therefore, imaginary part must be 0. Therefore, 8 sin theta 1 plus 4 sin square is 0. This implies 8 sin theta is equal to 0. This implies sin theta is equal to 0. We know if sin theta is equal to 0, then value of theta is n pi. N belongs to z. Therefore, this is the value of theta. Next problem, that is given. If z1 is equal to 2 minus I, z2 is equal to minus 2 plus I, find real part of z1 into z2 by z1 bar. That is solution. 1. z1 z2 by z1 bar. z1 means here 2 minus I, z2 is minus 2 plus I, z1 bar, this is conjugate of z1, therefore it is 2 minus I, therefore it is 2 plus I. We have to multiply, this is minus 4 plus 2i plus 2i minus I plus minus I square, 2 plus I. It is minus 4, 4i, 2i, 2i, 4i, and this is 1. And this is 2 plus I. Now minus 4 plus 1, that is minus 3 plus 4i by 2 plus I. Now we have to eliminate I from denominator. So 2 plus I, we have to write 2 minus I, conjugate of 2 plus I. So 3 plus 4i, there is also 2 minus I. This is 2 square minus I square. That is minus 6. Minus 3 into minus I, that is plus 3i. That is 8i minus 4i square. This is minus 6 plus 11i, this is plus 4 because I square is there. Therefore, this is equal to 4 plus 1. This is minus 6 plus 4, this is minus 2 plus 11i, this is 5. We can write this as minus 2 by 5 plus I 11 by 5. And what is the real part? That is the real part. Therefore, RE, real part of Z1, Z2 by Z1 bar is this is the real part, this is the imaginary part, so real part is minus 2 by 5. And next problem is imaginary part. This is next question, that is solution 2 as imaginary 1 by Z1 and Z1 bar, that is. We know this is not. Now 1 by Z1 bar, that is Z1 is, what is the Z value of Z1? We have got this 2 minus I, that is 2 minus I. This is the Z1 bar, this is 2 plus I, that is 1 by, this is 2 square minus I square, 1 by 4 plus 1, this is I square by minus I square is y square is minus 1, this is minus plus 1. That's 1 by 5. We can write it as a plus ib formula as I0. A plus ib. Therefore, imaginary part. What is the imaginary part? Imaginary part is 0. Therefore, imaginary part of 1 bar is 0. This is the problem. This is my last class for complex number. Next class, I shall discuss linear inequality.